Hi class, how are you today? Well, that's not a very linear way of thinking. The learning target for today is to graph linear equations. For the scale, you're a 3 if you can graph linear equations. You're a 2 if you can graph linear equations in slope-intercept form, so they're already in slope-intercept form, and you don't have to change them from another form, such as standard form or point-slope form. You're a 1 if you can graph linear equations, but you have to use a table. You can't just use the y-intercept and go up from the slope. You specifically have to use a table. And you're a 0 if you cannot graph linear equations using any method. Let's get started. All right, so the first thing we'll talk about is that most graph equations you'll see are written in what's known as slope-intercept form. And it's like this: y equals mx plus b, where m is your slope and b is your y-intercept. Now you may ask, where do x and y come into this? What are they? What do they stand for? Well, y is known as the dependent variable, and x is known as the independent variable. We say this because x is the thing that can always change. You plug a number into x and you get out a y. So whatever your y is depends on what your x is. So x is your independent variable. It can be whatever it wants to be. And y is your dependent variable. The value of y depends on what you have in there for x. So let's look at this equation now. We have y equals 2x minus 3. There are a couple different ways you can look into graphing. The first way that we'll look at is with a table. And we want values for x and y. So like I said before, the x is your independent variable. It can be whatever you want it to be. So let's pick some numbers. I'll just go with some easy ones: 0, 1, and 2. I prefer easier ones because once we put them in, they'll be easier to graph. And then we plug this in to the equation up top here. So if we plug in 0, we will get 2 times 0, because 0 is now x. 2 times 0 is 0, and 0 minus 3 is negative 3. Same thing for 1. 2 times 1 is 2, and 2 minus 3 is negative 1. And 2 times 2 is 4. 4 minus 3 is 1. And then we would plot those on the graph. Another way to do it is by looking at your slope and your y-intercept. So remember, as I just said, your slope is the number before the x, the 2 here, and your y-intercept is the number by itself, negative 3. It's minus 3, but we say that it's negative 3. So the first thing you want to do is look at your y-intercept. It's negative 3. So on your y-axis, and remember, your vertical axis is your y, your horizontal axis is your x, and on the y-axis, you plot negative 3. Then you look at the slope, which is 2. Anytime you have a number in front of x, you think rise over run. So you want to look at this as a fraction. So we'll put this over 1, because any number by itself is over 1. Then it's rise over run. So we go up 2 and over 1. And then we'll do it one more time. Up 2 over 1. Notice that the points we made, 0, -3 here, is 0, -3 here. Here we have 1, -1, 1, -1, and 2, 1, 2, 1. So they'll give you the same points either way. But it's good to always see the differences that each style uses. One is looking at what's the slope, what's the y-intercept. Other is looking at what happens when you plug in certain numbers. Now with these equations, we're always going to have a line. So connect the points and draw a line. And make sure you put arrows on the end to show that the line goes on forever in both directions. Alright, so the next thing I want to talk about is, what if you have an equation here, like y equals 5? We're missing something. There's no x. X is not there. What do we do with it? So, there's two things we can do. Again, the first thing we can do is a table. So we take our points 0, 1, and 2. I like using the same ones all the time because they're easy. So we have that. Well, when x is 0, what is y? Well, we see here y equals 5. Okay, so when x is 0, y is 5. What about when x is 1? Well, again, let's look. Y equals 5. Okay, that means once again we have y is 5. What about when x equals 2? Again, y equals 5. So every time, no matter what x is, we're going to get 5. Every time. No matter what we put in for x, we'll get 5. Because x doesn't do anything to this problem. It's not there. Y is just always 5. Another way you can look at this problem is back with our slope and y-intercept deal. Well, remember that the y-intercept is the number that's always by itself. Well, we have a number by itself here. It's 5. So our slope is the thing that disappeared. So what makes things disappear? Well, the number 0 makes things disappear. So this is the same thing as writing y equals 0x plus 5. So our slope is 0. There's no slope. The slope is 0. So we can graph this like we did before, and we looked at our y-intercept, and our y-intercept is 5. So on the y-axis, we'll plot 5, and our slope is 0. So that means we go up 0 and over 1. Up 0 and over 1. So every time, we're making more dots, and they're all next to each other. They're all on the same horizontal line, meaning our line will be a horizontal line. So we draw our line, put our arrows on it to show that it goes on in both directions forever. And every time you have y equals just a number with no x, it'll always be just a horizontal line, because it's saying y equals 5. So no matter what x is, on your y-axis, y will always equal 5 every time. So the y will always be 5, and you can follow that along as long as you want. So the last thing I want to talk about is, what if we have x equals a number? So here we have x equals -3. So this time the y is missing. So this changes things up just a little bit. That's because if we try to draw our table like we did before, we can't pick x anymore because x is always -3. So we can't pick 0, 1, 2 like we did before. X has to be -3. So that means our y is the thing that's going to change. So our y will be 0, 1, and 2. This is a special kind of equation, a special kind of function, and we'll talk more about this later. But for right now, let's graph our points that we have here. So we're always at -3 on the x, and then we have 0, 1, and 2. And then we make our line. Again, marking the arrows to show that it goes on forever. So when you had y equals a number, it gave you a horizontal line. When you have x equals a number, it gives you a vertical line. And you may have noticed that I didn't show the other way that we use to figure this out, about slope and y-intercept. Well, that's mostly because we don't have either. The line we have is vertical, so it's parallel to the y-intercept, to the y-axis, so that means it'll never touch. So there is no y-intercept here, and also we don't have a slope. There's no slope. It's a straight up and down line, and we actually call this an undefined slope. So this is a special kind of equation where it sort of switches our dependent variable and our independent variable, and we actually say that it's technically not even a function at all, but we'll talk more about that when we get talking about functions. Alright, so in this problem we have 2x minus 3y equals -15. So to solve for slope-intercept form, to put it in the slope-intercept form, remember it needs to look like this. It needs to say y equals mx plus b. So to get it in the form y equals mx plus b, we need to solve for y. So we need to get y by itself. Now, this can be a bit confusing because we've got two variables here. But it's actually not all that bad. So let's try it out. First, just like any problem, we have to undo what is happening to the y, and we have to undo the addition or subtraction first. So we look over here and we've got 2x. So we need to get rid of that 2x. So we need to bring the x over here, and in order to do that, it's a positive 2x, so we need to subtract 2x from both sides. So minus 2x minus 2x. So on the left side, the 2x is canceled to leave -3y. And on the right side, we like to put x first, so put the minus 2x and then the minus 15. Then, what is happening to y? It's being multiplied by -3. So now we need to divide both sides by -3. The problem here is if you divide something by -3, you need to divide everything by -3. So we divide -2x by 3 and -15 by -3. So what happens is on the right, or on the left, y is still y. On the right, notice negative divided by a negative is a positive. So it's going to be a positive, and then we say what's in front of x. 2 over 3. 2/3 x. Then over here, again, that minus still works as a negative, so negative divided by a negative is a positive. And 15 divided by 3 is 5. So we've got y equals 2/3 x plus 5. Then we graph it. So remember, first we plot the y-intercept, which is 5. Then we go up 2 and over 3, because up 2 over 3. So up 2 and to the right 3, and plot a point right there. Then connect the points with a line, making sure to put arrows on, and we have our line. So that's how you do this. It's already in a different form, so you need to bring the x to the other side. You need to divide by what's multiplying y, everything by that number, and then graph it. Y-intercept, then slope. Alright, let's do one more example. Alright, so here's another problem. We've got negative x plus 2y equals 6. So we need to start off by taking this negative x here and bring it to the other side. It's a negative x, so we need to add x to both sides. So plus x plus x. So on the left side, the x's cancel to leave 2y, and it's positive 2y because there was a plus there. And then that equals, and like I said, put the x first and then the number. So plus x means you just throw an x there. And then it's a positive 6, so plus 6. Now we've got 2y, so we need to divide both sides by 2 because it's being multiplied. So y is being multiplied by 2, so we divide. Divide by 2. That means we have to divide everything by 2, the x and the 6. So on the left side, the 2's cancel to leave just y. Now, in order to put this in slope-intercept form, you can't say just x over 2. You have to have a number in front of x. It can be a fraction, but it has to be a number. So what number do we say is in front of x when there's nothing there? Well, 1. Now, x is being divided by 2, so that means that number in front of x is being divided by 2. So, divided by 2. That means the number in front of x is 1/2. So now we put the x, and then plus 6 divided by 2 is 3. So plus 3. So y equals 1/2 x plus 3, and then we graph it. So we start with our y-intercept of 3, and then go up 1 over 2, so up 1 over 2 to the right. Plot a point right there, and connect them. Making sure you make a line that has arrows. Remember, those arrows show that the line goes on forever in both directions. For this, I'd like you to graph each equation. So number 1 is y equals 3x minus 1, number 2 is y equals 5, and number 3 is x minus 4y equals 8. So graph all 3 on a coordinate grid, take a picture of everything, submit it all to Google Classroom, and have a good night.